Alright, today we're going to talk about proving lines are parallel. I want you to think back to lesson 4.3 where we learned about corresponding angles, alternate interior angles, alternate exterior angles, same side interior, same side exterior, all those angle pair relationships that happen anytime you have two lines cut by a transversal. It creates those angle pair relationships. Now, this angle and this angle are alternate interior angles. They're on different sides of the transversal and they're inside the parallel line, so they're interior, alternate interior angles. Now, because these lines are not parallel though, these angles are not congruent. But as soon as we make sure that these lines are parallel to each other, then alternate interior angles are congruent. That's what we learned back in lesson 4.3, that if the two lines that are cut by the transversal are parallel, then alternate interior angles are congruent. Corresponding angles are congruent. Top right hand corner of this intersection, top right hand corner of this intersection. Corresponding angles are congruent. We also learned alternate exterior angles are congruent. Now all those things happen if the lines are parallel. Well, what we're going to learn today is that the converse of that is true. So instead of saying that if the lines are parallel, then these angle pair relationships are congruent, we say the converse. If the angle pair relationship is congruent, then the lines are parallel. So if I got two lines, and I don't know if they're parallel or not, but let's say I know that this angle is 80 degrees, and I know this angle is 80 degrees, these angles are congruent. And those are alternate interior angles. And so because alternate interior angles are congruent, I know that these lines have to be parallel. So it's kind of the same concept, but we're working in reverse order. We're doing the converse. We first know that these angles are congruent, and because of that, we can say that the lines are parallel. So we are using these angle pair relationships that we learned previously, and we're using those to prove that lines are parallel. So two coplanar lines are parallel if they are cut by transversals so that the following pairs of angles are congruent. Corresponding angles, alternate interior angles, and alternate exterior angles. Now the names of the postulates and theorems are written over here so that when we use these to do proofs, you'll know how to refer to this situation. Now, what we learned in 4.3 was called the corresponding angles postulate. That was the one that said that if the lines are parallel, then the corresponding angles have to be congruent. The converse of the corresponding angles postulate is the one that says if the corresponding angles are congruent, then the lines are parallel. Same concept here. This is the converse of the alternate interior angles theorem. So if I know the alternate interior angles are congruent, then I know the two lines have to be parallel. The converse of the alternate exterior angles theorem. If I know the alternate exterior angles are congruent, then I know that the two lines have to be parallel. Now, not all those angle pair relationships are congruent when the lines are parallel. Some of them were supplementary. Same side interior and same side exterior angles were supplementary when the lines are parallel. So the converse of these would be that the lines are parallel if they are cut by a transversal so that the following pairs of angles are supplementary. So the converse of the same side interior angles theorem says that if same side interior angles are congruent, then those two lines have to be parallel. Converse of the same side exterior angles theorem is if same side exterior angles are supplementary, then the lines are parallel. So these types of angles need to be supplementary to prove that the lines are parallel. These types of angles have to be congruent to prove that the lines are parallel. Alright, let's look at example 1. Tell what type of angle pair each is, and then tell whether they need to be congruent or supplementary to make lines are and as parallel to each other. So, angle 1 and 3, top left-hand corner, same part at the two different intersections. These are corresponding angles. And corresponding angles have to be congruent for the lines to be parallel. Okay, angles 2 and 6. Here's 2 and 6. Notice they're on different sides of the transversal, so they're alternate. They're in between the two lines, so they're interior. These are alternate interior angles. And alternate interior angles also have to be congruent for the lines to be parallel. Angles 4 and 8. Notice they're on different sides of the transversal. One's above it, one's below it. And these are outside the two lines, so these are alternate exterior angles. And alternate exterior angles also have to be congruent for the lines to be parallel. Okay. Angles 2 and 3. Angles 2 and 3 are both on the same side of this transversal, and they're in between the two lines, so they're interior. So same side interior angles. Now, same side interior angles are supplementary, or need to be supplementary for those two lines to be parallel. And one way you can remember that, the two angle pair relationships we learned that start with S are supplementary if those lines are parallel, or they have to be supplementary to make the lines parallel. And then angles 1 and 4, again, same side of this transversal. Now they're outside the two lines, so they're exterior. So those are same side exterior angles. And they need to be supplementary also for those lines to be parallel. Alright, so let's look at example 2. It says for each of the examples below, will line L and M be parallel? If so, which postular theorem proves they are parallel? Alright, well let's look at this. Angle 1 and angle 5. What angle pair relationship is that? Those are alternate exterior angles. They're on different sides of the transversal. One's to the left, 5's to the right. And they're outside the lines. Alternate exterior angles. And if you remember from the front page of the notes, alternate exterior angles have to be congruent for the lines to be parallel. Are they congruent? Yes, they are. They're both the same measure. They have equal measures. So, yes. Will the lines be parallel? Yes, they will. And if so, which postular theorem proves they are parallel? If alternate exterior angles are congruent, and therefore we're saying the lines are parallel, that's using the converse of the alternate exterior angles theorem. Converse of the alternate exterior angles theorem. Alright, let's look at B. Angle 2 and angle 3 are what type of angle pair relationship? They're on the same side of the transversal, and they're in between the two lines. Those are same side interior angles. Now we learned that if those lines are going to be parallel, same side interior angles have to be supplementary. Are they supplementary? Supplementary means they add up to 180 degrees. 70 plus 110, that would add up to 180. So they are supplementary. So that means that those lines will be parallel. Yes, the lines are parallel. And same side interior angles, if same side interior angles are supplementary and therefore the lines are parallel, that's using the converse of the same side interior angles theorem. All right, let's look at angles 1 and 4. Angles 1 and 4 are on the same side of the transversal, and they're outside the two lines, so those are same side exterior angles. We learned that same side exterior angles have to be supplementary for the lines to be parallel. Are they supplementary? They're congruent, but they're not supplementary. If I add 125 plus 125, it's not going to equal 180. So because those same side exterior angles are not supplementary, that means the lines will not be parallel. All right, let's look at example 3. What value of x would make lines L and M parallel to each other? Well, let's see what type of angles we're working with. These right here are same side interior angles. We learned same side interior angles have to be supplementary for those lines to be parallel. So let's find out what value of x would make them supplementary. So remember, supplementary means that if I were to add these two together, it would equal 180. So there's the equation. Whatever value of x works for that equation is the value of x that's going to make those lines parallel. So combine like terms. I got 6x's. 8 minus 32 is a negative 24. I'm going to add 24 to both sides. And then we can divide off the 6. 34, I believe. Alright, so if x is 34, that's going to make those lines parallel to each other. Alright, last one. Let's take this information and let's do a proof. Okay, when we do a proof, we always start with the first given. It's given that lines L and M are parallel. Okay. Our goal is to prove that lines R and P are parallel. So if I'm just thinking through this, lines R and P, I see a couple of angles along the same transversal for R and P. Angle 2 and 3 are alternate exterior angles. If I can show that those alternate exterior angles are congruent, that would prove that these two lines have to be parallel to each other. So in my quest to say that these are parallel, I need to show that angles 2 and 3 are congruent. Well, I know that L and M are parallel. Because they're parallel, angle 1 and 2, here's two parallel lines, here's a transversal. 1 and 2 are corresponding angles, so when those lines are parallel, I know angle 1 and 2 have to be congruent. That's using the corresponding angles postulate. Notice I didn't say converse, because in this particular situation, I already know that these lines are parallel, and because the lines are parallel, I know the corresponding angles are congruent. Okay? The converse is when we go the other way. If I already know the angles are congruent, then I can say the lines are parallel. That's what we're going to use later. So I figured out these angles have to be congruent because they're corresponding angles, and these lines were parallel, so they have to be congruent. Corresponding angles postulate. Go back up. I'm going to take the next piece of given information, which tells me that angle 1 and angle 3 are congruent because it was given. Now remember, in my brainstorming, to show that these are parallel, I need to know that angle 2 and 3 are congruent. Well, angle 1 is congruent to angle 2, and angle 1 is also congruent to angle 3. So I know that angle 2 is congruent to angle 3, and that's called the transitive property. Basically, when two different things are congruent to the same thing, then they're going to be congruent to each other. I would also accept substitution property here. You could say I'm taking this right here and I'm substituting the 2 in place of the 1 because they're congruent. I can replace one with the other. So if I substitute that in, now I have angle 2 is congruent to angle 3. So either way you do that, one would be acceptable to me. Now because angle 2 and 3 are congruent, I can finally finish my proof and say that lines R and P are parallel, because if alternate exterior angles are congruent, then these lines have to be parallel, and that was the converse of the alternate exterior angles theorem.